Now we're going to find the area enclosed between the curves of the absolute value of x and x squared minus 2. In our case here, it's we try to learn what we can do to find the area. And I think the first step that we're going to do is we can graph these simple functions. So we know how to graph the absolute value of x. Okay, and the x squared minus 2 is just the function x squared shifted 2 units. Okay, it's okay, let me just, I'm gonna do it in a different color, so it's gonna be, so this is minus 1, minus 2, and it's gonna be something like this. Okay, approximatively. Okay, so I'm not gonna do the other part, and we're gonna see why. Because here we're gonna get a symmetric part here, and the area is gonna be symmetric, and therefore to find this area is to find it twice because it's symmetric with respect to the y-axis. So it's better to find it just here. Okay, this one we find this area and we multiply twice. Okay, so if we have a function that's even, this is the key idea, and we are integrating between minus a, and if f is even, okay, the area is between 0 and a of f of x dx, but it's multiplied by 2. And that's what we're gonna do here. Okay, why? Because in our case here, the area that we are trying to find for x bigger than 0 is the area between this point here where these two graphs, okay, so this is 0, and the point where these two graphs intersect. Okay, to find that, we need to have sort of the absolute value of x is equal to x squared minus 2. But since x is positive, we're gonna worry only about the positive part. So we're gonna have x is x squared minus 2. To solve this equation, we add minus x to both sides, and we're gonna factor here by 1, and we add 1 to this side. So we're gonna have minus x plus 1. Therefore, we have x plus 1 times x plus 2. Therefore, we have x is 1 or x is minus 2. We don't care about the negative one because we are only worried about the positive one. Therefore, these two, okay, minus 1. Did I make a mistake here? They should intersect in 1, but I don't see that they intersect. Did I hurry up here? So here I add 1 to both sides, so I split these two, so I get minus 1 minus x minus 1. So I have x minus 1, x plus 1, minus x plus 1. So it's gonna be x minus 2 plus x plus 1. This is the mistake that I made. So therefore, x is 2 or x is minus 1. I'm not gonna worry about this. So I'm worried about this point here. So the upper limit where they intersect is 2. So my integration is gonna be between 0 and 2, okay? But my function is gonna be f, and this is g. This is g, this is f. So my integration, or my area, is gonna be between 0 and 2 of x minus x squared minus 2 dx. Okay, therefore I can do it this way, between 0 and 2, x minus x squared plus 2 dx. Now using the power rule for integrations, okay, so here I have x squared over 2 minus x cubed over 3 plus 2x between 0 and 2. Okay, I can go ahead and compute, but this is just simple algebra. For 0 I get 0, but for 2 I get 4 over 2, which is 2 minus 8 over 3 plus 4. So I get 6 minus 8 over 3, which is gonna give me, let me see, maybe I can do better. I can multiply by 3 here, and I get 10 over 3. Okay, so this is the area enclosed between the two curves, and I think that's all we need. So the key idea to find the curve enclosed between two functions is to find the lower limit and the upper limits of integrations. So that's why you have to solve to see where the two functions. Sorry, I made a mistake here. I need to multiply this one by 2 because I am computing only this part. So that's the one I forgot. So now if I multiply this one by 2, I get, let's call this integral. This is the integral. So let's call this one I is 2 times this. So I is going to be 2 times 3 over 10, which is going to be 20 over 3. So that's the mistake that I was going to make. So here, to find the area is draw the graphs to see what are you integrating, okay? And see which one on top of the other. Okay, because we're gonna do examples when we're gonna see that sometimes f is on top of g and g is on top of f. But here we have f of x is bigger than g of x. That's why we don't care about the absolute value. In fact, the area enclosed between the graphs of two functions is gonna be the integration between a and b, f of x minus g of x, absolute value of d of x, because we don't know which one is on top of the other. Okay? So that's why we have to be careful. But here in our case, f of x, which is x, is bigger than x squared minus 2 when we are here between 0 and 2. And I think that's all we needed for now.